Day 15 of 90, and today we fixed the bug that makes seasoned C# developers lose an entire afternoon. You spin up an ASP.NET controller, hit the endpoint, and boom, null reference exception. The repository field is null. But you wired up dependency injection correctly. The culprit? Your class has two public constructors, and DI quietly picked the wrong one. By the end of this video you'll design constructors that make that bug impossible. Let's build classes that can't betray you. Here's the trap. You have a parameterless constructor sitting next to one that takes iRepository. ASP.NET's container sees both, grabs the simplest one it can satisfy, and hands you an object with null dependencies. No error at startup. The crash comes later, at request time, far from the cause. The fix is brutally simple: delete the parameterless constructor. Now DI is forced to use the one that actually injects what the class needs. Your constructor is your class's contract. If it can be called without the things the class requires, you've written a trap, not an API. Let's build up properly. A class bundles state and behavior. Fields hold the state, private read-only iRepository_repo. That read-only keyword matters. It means once the constructor sets it, nobody can swap it out. Initialize fields in the constructor, not with scattered defaults. When you mark dependencies read-only and assign them in one place, every reader of your class instantly knows these are required, they're set once, and they never change. That's clarity you get for free. Now constructor injection, the heart of ASP.NET. Public order service, iRepository repo, iLogger order service logger. One constructor, all required dependencies, listed explicitly. The DI container reads this signature, resolves each parameter from its registrations, and constructs your service. No ambiguity, no guessing. The parameter list is your dependency graph, readable at a glance. If order service genuinely needs a repository and a logger, demand both right here. A dependency that's optional in the signature is a dependency you'll forget to provide. Repeating null guards in every service gets old fast. Enter constructor chaining. Create service base, iLogger logger, that does the null check once and stores the logger. Then email service, SMS service, and push service each declare their own constructor and call base logger. Public email service, iLogger email service logger, ISMTP client SMTP, base, logger. The base runs first, handles shared setup, then the derived constructor adds its specific dependency. 3 services, 0 duplicated boilerplate, and the inheritance chain documents itself. C number 12 makes this even cleaner with primary constructors. Instead of declaring fields and writing assignment lines, you put parameters right on the class: public class order service, iRepository repo, iLogger order service logger. Those parameters are now in scope across every method. No field declarations, no assignment ceremony, the dependencies are just there. For DI-driven services, this cuts the boilerplate dramatically while keeping the exact same contract. One line tells the container everything it needs to wire the class. For data, combine primary constructors with init-only setters. Public class user settings, public string theme, get, init. The init accessor lets you set the value during object creation, then locks it forever. You get a fully immutable settings object, set once at construction, safe to pass across async task chains in a WPF service with 0 defensive copies. No method can mutate it behind your back, so no race conditions, no surprise state changes 3 awaits later. Immutability turns a whole category of bugs into compile errors. Sometimes a public constructor is the wrong tool entirely. When creating an object requires validation or business rules, reach for a static factory method. Make the constructor private, then expose public static order create from checkout, cart. Inside, validate the cart, check the totals, reject empty orders, and only. Then call the private constructor. The factory's name documents intent, it can return a result or throw a meaningful exception, and it guarantees no order ever exists in an invalid state. Constructors initialize, factories decide whether creation should happen at all. Let's wire it together. Register it, builder services.addScope order service. Then a minimal API endpoint, app.mapPost, // order service SVC, checkout DTO equals SVC, process, DTO. The container sees order service single primary constructor, resolves iRepository and iLogger from registrations, injects them, and hands the endpoint a fully formed service. One valid path to construction means DI cannot pick wrong. The runtime crash from minute 1 is now impossible by design. Day 15 done. The takeaway: one public constructor with all required dependencies makes broken objects unrepresentable, chain bases to kill boilerplate, use init for immutability, and factories for validation. Subscribe for day 16.